Hello students. We will be discussing today current electricity chapter. In the previous video we discussed electrostatic potential and capacitance, and now today we are going to discuss the topic of current electricity. So we will be covering a majority of the concepts and some questions also based on that, and we will be doing some questions based on series and parallel combination of resistors also. So let's start. So the first concept is basically related to what? The first concept is related to the definition of current. So when we define current, please understand, whenever we define the value of current, what actually happens is that electric current is the time rate of flow of charge through a given cross-sectional area. So very simple definition. Suppose you are having a cylindrical cross-sectional area, and let us suppose the area of the cross-section you are taking it as A. Then if in dt time some dq amount of charge flows through that area, then the current will be given by I is equal to dq by dt. Now here there are basically two types of current. One is average current and one is instantaneous current. When we talk about average current, then the average current will be given by total charge flown divided by total time taken. In delta t time, let us suppose delta q amount of charge flows, then what will be the value of average current? It will be delta q by delta t. And if you talk about instantaneous current, then the instantaneous current will be equals to what? The instantaneous current will be equals to dq by dt. So for instantaneous current, let me write. For instantaneous current, I will be equals to dq by dt. So instantaneous current is the current at a particular instant of time, and average current is the current in a particular interval. So this is basically the definition of instantaneous and average current. Instantaneous current and average current have unit amperes. The unit of this particular current is amperes. It is a scalar quantity, and the direction will be always along the movement of positive charge or opposite to the flow of negative charge. So always remember, the direction of current will be in the direction of flow of positive charge or opposite to the direction of flow of negative charge. Remember one thing, actually positive charge does not flow. In the actual sense, in the conducting wires, the electrons only flow. But by convention, if you take instead of electrons, you take an equivalent positive charge also, then also there will be no problem. You can definitely use the convention of flow of positive charge for the definition of current. But remember one thing, even though current has direction, which is the direction of flow of positive charge or opposite to the direction of flow of negative charge, even though it has direction, but still it will not be considered as